We're going to start our discussion of Chapter 4-5 by reviewing what we know about areas and specifically areas of squares. So in example A, we have a square and its side length, the bottom side is 7. But we remember with a square that all sides are equal. That means the vertical side is also 7. And when we're finding the area, we're looking for the space inside the square. And to find the area of a square or any rectangle, area is length times width. So for example A, length is 7 and the width is 7, so 7 times 7. And we know that 7 times 7 is the same as 7 to the second power, or 7 squared, and that's 49. So the area of square A is 49, the space inside. All right, so I'd like you to go ahead and complete examples B and C, and I would like you to show your work the same that I did. There's a reason I'm asking you to do that. And also, while you're doing that, think about why do they call something to the second power? Why do they call that squaring a number? Okay, we're going to shift gears just a little bit and remind ourselves what we mean by inverse operations. Remember, inverse operations undo an operation that we just used. So it gets us back to where we just were, back to where we started. So the inverse operation of addition, we remember, is subtraction. We undo multiplication by dividing. So how are we going to undo squaring a number? Well, we call that taking the square root. So if I wanted to undo squaring the variable x, I would take the square root of x squared. So the square root is how we undo squaring a number. Let's look at a little vocabulary. A perfect square is a number that has two identical integer factors. There's a little typo there. There's a word missing. Integer factors. A perfect square has two identical integer factors. So 25 is considered a perfect square because 25 has factors of 5 times 5, two identical factors of 5. Or also 25 has the factors negative 5 times negative 5. That also equals 25. So 25 is considered a perfect square. Okay, so let's tell if a number is a perfect square, write yes or no, and then write the identical factors. 121. Are there two numbers we can multiply by themselves, a number we can square, to get 121? Well, the answer is yes. 121 is a perfect square because we can take 11 squared to get 121, or we could also take negative 11 squared to get 121. How about 200? Is there anything times itself that will equal 200? Something squared that equals 200? Well, the answer is no. So 200 is not considered a perfect square. And then what about 400? Can we square a number to get 400? Yes, we can. What number do we square to get 400? You figure that out for me, and notice there's going to be the positive number we square and also the negative number. See if you can figure out what squared equals 400. Then also, so that number then that we square is called the square root. So 25, the number 25, we get that by squaring the number 5. So if we want the square root of 25, what did we square in order to get 25? We want to undo that. The answer is 5. The square root of 25 is 5. But remember, we could have squared negative 5 to get 25. So 25 has another square root. The negative square root of 25 is negative 5. So notice square roots actually have two roots. They're going to have a positive root and a negative root. So the square roots of 25 are 5 and negative 5. The positive square root is called the principal square root. That's the positive square root. Okay, so there's quite a bit of vocabulary there. You may want to take a minute to take some extra notes on those or think about those a little bit. All right, so let's practice finding square roots. We're going to write the two square roots. Remember, there are two square roots of each number. The square root of 81. What did we multiply by itself? What did we square? What number squared gives us 81? That would be 9. So 9 is a square root of 81, but also negative 9. So the two square roots are 9 and negative 9. What are the two square roots of 625? Well, they're 25 and negative 25. Now let's see if you can figure out what the two square roots of 169 are. So you work on that one, and when you're done, let's go down here to example 7. Write the principal square root of each number. That means what's the positive square root? So the square root of 144. What number multiplied by itself, what number squared gives us 141? That's 12. What number squared will give us 6,400? Well, what number squared gives us 64? Okay, and then we've got some extra zeros. So 8 times 8 is 64. 80 times 80, there's our two extra zeros right there. So 80 is the square root of 64. Okay, you go ahead and see if you can figure out what is the square root of 10,000, the principal square root. All right, so of course the reason we want to learn about square roots is so we can use them and evaluate them in different expressions. So when you are evaluating a square root, when you have to evaluate with a square root, you're going to use the principal square root. Use the principal square root or the positive square root when you evaluate. And then square roots work just like exponents in the order of operations. So you can think of a square root with an exponent. So you would do parentheses first and then the square root. So let's do some examples. Number 10. Oh, also, notice when a number is directly in front of a square root, that's just like when a number is directly in front of a parenthesis. So, and what does that mean? It means we multiply. Okay, so 3 times the square root of 144 minus 20. That's how you read that expression. So what is the square root of 144? It's 12. 3 times 12, 36. 36 minus 20 is 16. Okay, when you have a problem like example 11, where there's operations going on beneath the square root, well then you have to kind of imagine there's some parentheses under that square root. You need to do the work underneath the square root before you take the square root. So we have to add 25 plus 144. That's 169. So now we're looking at the square root of 169. I asked you to figure that out a little bit earlier. Hopefully you figured out that the square root of 169 is 13, and 13 plus 13 is 26. All right, let's take a look at 12. That one's a little different. We're taking the square root of 100 over 25. The square root of 100 divided by 25. Well, you can break up, when you have division, you can break up the square root into two parts. You can take the square root of 100 divided by the square root of 25. You can't do that with the addition, but you can do it with the division. So the square root of 100 is 10. The square root of 25 is 5. So 10 divided by 5 is 2, and 2 plus 1/2 is 2.5. Okay, but notice something. Check this out. What if we took the square root of 100 divided by 25? Well, what is 100 divided by 25? It's 4. Well, what's the square root of 4? It's 2. So notice when we have division going on beneath the square root, we can actually have choices. We can break the square root up like we did in our example, or we can evaluate what's below the square root and then take the square root. We have choices. Choices are good. Why don't you go ahead and try these two on your own, see how you do with that. Okay, this problem's a little different. Find the side length of each square given its area. So we know that the space inside the square is 64. The area is 64. Well, how did we get 64? We multiplied the side by itself. In other words, we squared some number, x. And we squared that, and we know that it equals 64, the area. Well, we want to find x. So how are we going to find x? Well, if we know we're going to undo x squared, we're going to take the square root of it. So we are going to undo the 64, square root of 64. Well, the square root of 64 is 8. That means the square root of x squared, or x, must be 8. So the side length is 8. Okay, part B. We know the area is 36. So we want to know, what did we multiply together to get 36? We ask ourselves, what is the square root of 36? And it's 6. All right, you go ahead and do C, and please show your work. All right, let's go a little bit further now and look at a story problem. Switzerland's flag is a square, unlike other flags that are rectangular. If the flag of Switzerland has an area of 81 square feet, what is the length of each of its sides? Well, the area is the space inside, so we know that we're talking about 81 is the space inside. If we want to know the side length, well, how did we get the area? We had to square a number. So to undo that squaring, we're going to take the square root. So we need to find the square root of 81. Square root of 81 is 9. Okay? And this is a story problem, so we'll end this up with a really nice sentence. What is the, remember, look at your question, what is the length of its sides? So you could just say something like the length of each side is 9. And what are the units? Well, the units of the area were square feet. We don't have square feet, we just have regular feet. So the length of each side is 9 feet. All right, you're going to go ahead and try the second one and see how you do with that.